when I guess I can begin, and yeah, I'll share my screen and whatnot.
Did you make him co-host?
Aren't you supposed to make him co-host?
I can't.
Wow. All right, I'm co-host now.
There we
So
go.
Yeah.
cool.
It's live streaming.
Okay.
Yeah, yep, I see it's live streaming.
Okay.
Yep, I see all this. Don't worry. Someone that's been in those shoes before kind of knows the deal. So
Yeah.
You want?
but yeah, just making sure you like the in-person room can hear me clearly, right? And hear me
Yes.
well. All right, cool. Yeah. Awesome. Well, yeah, but no, that's cool. Yeah, I know Kayla told me that everyone's busy with midterms, so that's cool. It's a cool thing that now we can record this sort of stuff, so people can watch whenever. So
Thank you, guys.
that's cool. But yeah, go ahead and just give me the green light on, I guess, when I can start.
The language.
All right.
Yeah.
I'm gonna go ahead and
No
stop
rush.
sharing. Hope everyone was able to sign in.
All right,
I don't know what Kristen.
I'll just go ahead.
I know.
Let me bring my, let me
You could put double.
this first.
You put it. It was 30 minutes ago.
I know.
Wait, Ketan, is most of your work like remote or in person?
You're asking if my work is remote or in person?
Yeah.
Right now, I'm working purely remote. I actually, the office that I work at or supposed to be working at in person is in it's in Burbank, but I'm not living in Burbank right now. I'm living in my hometown in Bakersfield. But I'm in the middle of like trying to find like spots to live at. So, and then once I move out there, then I'll be like going in person probably sometimes because.
Burbank is like near JPL, I think, right?
What was that?
Burbank is near JPL, right?
I believe so. I'm not entirely sure, to be honest.
Just start hanging outside of JPL. Yo, you guys any hires?
Okay, let me.
Do they pay?
Okay.
I don't know, by the way, JPL is a government company. I don't know whether they're gonna pay as well, for software engineer. I don't know they're gonna pay as well like Paramount. Because like Paramount Plus is like a massive streaming platform. Compare that to
Then can you really compare the stability of like the government job versus
Why
like
is
top
this?
job?
well, when
Let me stop sharing again and let me.
stability too.
This glitched.
If you get a job, get a
Stability. Just saying, like when those like
I'm sorry. If Congress if Congress cut budget for NASA, you're gonna see layoff from JPL.
Yeah, of course, but then they have to cut off the budget versus
One
like
second.
company randomly firing you because like they want to cut off the expensive, like, well,
You're assuming the government is not gonna randomly cut off spending from,
then in the government, how many other people do you really have competing against you versus like, a famous company?
I think like the reputation. of NASA is up there.
Exactly.
Oh, yeah, for sure.
Up there.
I'm talking like government in general,
Like local government jobs.
just any government job that would accept like a software engineer. I feel like there'll be more stability. You wouldn't really have to worry so much.
I would agree with that, especially for like state position.
Yeah.
Like I went to the river. I talked to like a CTO, like a CTO over at the Orange County. They're looking for they're looking for a new grad to for development. And they were like, you don't need to worry about any coding to them, getting to them. It's just like talking, they see how they communicate, that kind of thing. They ask you about what tech stack are you familiar with, familiar with, and like maybe they'll ask you like a kind of question, like maybe we want to do if for example, I actually remember seeing I applied. So like internship program for like state offices for software engineering. One of the questions that they asked me was like, suppose you were tasked with building a public API to handle a COVID data web portal. Or like a local COVID data web portal.
Do you think
Are you
those
gonna,
people would be
how are you gonna go about defining the API as well? And
Like,
like,
would it be louder?
and you know, like this API should be accessible. The data should be accessible, but publicly through a public API and through like, make it available to connect to a website as well. But because it is a COVID web portal. But if any data that wants to be updated at that portal, it has to be done privately through an kind of an administrative account that government people have access to. So how would you do that? And COVID data, there's a lot of people who have problems with COVID, billions of people, billion rows of data. How are you gonna address that? And COVID data, a lot of people search that up as well. Certain that up as well, like how are you gonna deal with that's trying to scale up? How are you gonna do that? So very system based.
We need a lot, we need a lot more like software engineers and the type security
Can you speak more?
like a lot of government
Hello,
websites
hello,
that
testing.
need to break into. I mean,
Testing.
a
Can
lot
y'all hear me?
of other people.
Let's be honest here, a lot of people use COBOL.
Not sure.
Yeah,
They need to stop using COBOL, I'm sorry.
And like the websites are super unupdated.
This is why I feel like
Yeah, but
most
it's real
governments around the world,
Testing,
like,
testing.
I don't know
Hello,
why.
hello.
Have the
You
volume.
wanna get a
down.
stable job in software engineering, like ask government offices to be like, okay, do y'all have any positions that you need, someone who's doing cybersecurity? You need someone to update your like, no offense, but your web portal looks like ass. Your COVID web portal looks so terrible. Your authentication system for like, verifying whether you have COVID,
Actually, increase volume and like you like
Isn't it? I think it's already 100%. For the login is already.
like, yeah,
Oh wait, like it should be at 100%.
government jobs is a very good way to say.
It's right click the
Like, especially local government.
right click
It's a really good way to, I think, it's a really good way to secure them, but like, I do wanna try my boomer. I do wanna test my at like a large corporation for one, just for one, either as like a new grad job or
Fine.
some kind of internship.
Hello, hello. Can you hear me?
Yeah, with the environment.
Or can you hear me well, I should say?
I definitely not gonna.
Yeah, we can hear you well on this side, Keaton.
I feel like if you.
Okay, but in person, is it?
School.
I think y'all can see my screen now.
Yeah, I
Yes,
should
we
see
see
it.
it.
Okay, cool. All right, so then I guess shall I proceed or? If in person can hear me well, then I guess we can start. All right, then. It looks like more people are settling in too. All right, well, yeah, I guess I can begin. Well, hello, everyone. Thank you for CSS for bringing me back to do this GoLang workshop. It's actually something I've kind of thought about showing off for a while. So yeah, pretty excited to show this off. So just go ahead and, before we begin, just in case, people don't really know about me, and before we start this off, I like to, I guess, present a little bit about myself. So I am a CPP alumni, just graduated in December, a couple months ago. Doesn't seem too long ago, but yeah, it's been kind of wild. But I was actually a previous CSS. I served in the CSS eboard ever since August of 2020. So it was my second year of college. I came in as a public relations officer, and then vice president after that in the next year, which would be my junior year. And then being president in my last semester, actually, just in the fall 2022 semester. So, but right now, currently software engineer at Paramount, and my current interests, like with CS, I have grown an affinity towards like machine learning and AI applications. as well as back-end development. And then outside of CS, I like pretty much things like all tech related, like computer hardware, video gaming, Internet of Things, gadgets, all that sort of stuff. So yeah, so I guess it's not too surprising why I chose this route, right? But yeah, this is a little bit about myself. So and then also I do want to say if there's any questions throughout the presentation, just feel free to like you can interrupt me, it's fine. And or you can also for anyone that's in the Zoom chat, you can drop it in the Zoom chat. So or you can unmute yourself. That's fine with me. But yeah, let's go ahead and let's proceed. So this will just be a general outline of what I'll be talking about. So the history of the language, it's popular in use in the present day, and what I think why people should learn or know it. I'll be kind of going over its notable features, and then I'll be going over some of the demos in the about the language. So yeah, hopefully that's cool. But anywho, so the programming language was originated by 3 people that worked at Google: Rob Pike, Ken Thompson, and Robert Graceheimer. And it's started in 2007. So it's actually I mean, now it kind of seems like a while, but it's still pretty recent, considerably so. And it released in 2009. So why did Go or GoLang, what was the motivation behind creating it? So what they wanted to do was create, the ease of an interpreted dynamically typed language, something like, Python, right? You'll associate with that. But you want to combine that characteristic with with an efficient, safe, and the performance of a statically typed compiled language. So and you can associate that with like C or C++, right? So well, I think of GoLang as if Python and C++ had a baby, because that's what it seems like. Another language called Julia, I think, kind of shares the same characteristic, but that syntax is a little bit different. So Go is a statically typed and compiled language. When you compile the language, it gets directly converted into machine code. It's pretty fast. And the syntax of this language is much like C++. So if anyone already has been learning that or knows it, learning Go wouldn't be too much of a learning curve, to be honest. So I think that's a cool thing. And another, I guess, motivation why the language was created is to just be an improvement upon the latter programming languages at the time. So has things like a garbage collector. That's something that Java has as well, but I think Go handles it better. And then also has a built-in memory safety mechanism, which is really good when creating applications that use a lot of memory. And yeah, so this sort of stuff actually I'll be elaborating on further, but I will move on. So yeah, I mean, a lot of people might not really know it, but it is a pretty popular language. And when I say popular, it doesn't mean it's like the #1 language that everyone's going to right now, right? It's more so that it's growing. The trajectory and how it's growing is pretty, it's getting up there, right? So as you can see with some of the graphs I have up there and the statistics on Google Trends, it's going up there, right? And according to 2020 survey by HackerRank, it's the #1 language that devs want to learn. And then as you can see on GitHub has this popularity ranking, and it's 3rd actually. So And I guess I can also speak like how I ended up learning the language, or like how I got introduced to it. It was actually in my first internship, with when I was working like with Toyota. They suggested, or like before actually working on the internship, they wanted me to they wanted all the interns to learn Go. And I was like, huh, interesting. And at the time, this was after my freshman year, I was like, oh, okay. I mean, I may as well take this on. I mean, I know it's a risk. I don't really know even too much. My programming skills weren't even like that well, like being a freshman. I wasn't really too proficient already. So taking on this boot camp, I I felt two ways, like, oh, this is gonna be fun. I think I'm gonna learn a lot, but also too, like, it's gonna be a lot of work. And I'm not sure how I'm gonna manage things, but I'll try. But I think it was a good learning experience overall. Actually, I think it did make me a little bit more confident in like being a programmer and whatnot. So yeah, so that's how I learned Go. And as I mentioned, Toyota was using it, and like various other companies use it as well. Like Paramount, the company I work at right now, they're using it as well too, for like their backend servers. So I think a lot of companies are going to end up using it, especially if you're working on the back end, you're working on the server side of things. And actually, yeah. Now, if you dive into the use cases, as I mentioned, like with companies using it for the server side development, it's very popular for that on the back end, because of its efficiency. Also, network-based programs. When I get into some of the features, you'll know why people dive into that. And with any cloud native paradigm-based developments, because of all the notable features that I'll be talking about, and it being efficient, with server side, and it being able to perform a lot of tasks, at once, and in the world of programming, that's like referred to as like, concurrent programming, which I'll get into. That makes it just like a go-to, like, all right, so since it has all these features already built in, or it can enable these features pretty easily. It's a go-to when doing some cloud-based development. So now if we dive into some of the features, and I guess sort of giving a reason as to why people should learn GoLang, it's as I mentioned, a lot of businesses are starting to use it because of the language supporting multiple features, such as one, concurrency. This is a very needed feature, and it's very necessary, especially if you're, as I mentioned, like on the back end working with servers, because for example, if you're making a web application that needs to support a lot of server side activity, such as when users are logging into your applications, or users are making all these API requests, right? And you have to be able to handle a lot of that, right? Because it's not just going to be a couple of users using it, right? When your application gets very popular, and it rises, you don't want the application to break, right? Because of all this activity happening. So being able to handle various requests and functions, for example, and performing all that is very important, especially like, and if you really want to learn more about concurrency just on a conceptual level, I'm not sure which class in Cal Poly it is. I never took the class, to be honest, but I think it's one of those like those like I forget which one. I don't know if they still have it, but it was like a performance computing class or something. But yeah, or you can just search it up. But I think it is a pretty interesting topic if you want to learn about that. But this also falls into the concept of scalability. And if your application can handle a lot of activity happening, you should also be able to grow. For example, you should be able to grow your server and implement new functionalities, for example. So I think the two go hand in hand together. GoLang makes it happen pretty easily. And then some other features like error checks. Now, most languages should implement error checks. They do, right? But I think GoLang does it in a pretty interesting way. With a lot of like built-in functionalities that you might be using, it'll always return you can always catch an error if you want to, with just like 2 lines of code, rather than having to do a try catch block if you're using Java, for example. It's a little bit just like easier to write. So when you have that easeability, I think it just it speeds up your development process too, which is always a nice plus. And then as I mentioned, it is a compiled language, much like a lot of languages, Java, C++, right? But I think GoLang does it at a faster pace, because as I mentioned, converts directly into machine level code. There aren't as many steps in the compilation process compared to, like, as I mentioned, with Java or C++. So and then lastly, a garbage collection, which isn't a new feature, right? Java has the feature too, and but C++ doesn't have a garbage collector, right? If anyone knows anything about C++, you have to do a lot of the memory management yourself, which many people do like, but sometimes it kind of can get a little bit complicated, right? If you have to just do things yourself. I think whenever something can just be automated or something is built in, while also giving you the capability to do it yourself, I think that's always a nice plus. So GoLang enables you to do that. But yeah, so those are some of the features. And right now I'll talk about concurrency and more in depth and more specific to GoLang now, right? So as I mentioned, with concurrency, essentially what it is for a program to do multiple actions or functions at the same time, while those functions being independent of each other, right? So in programming, you can actually this can be done in, as I mentioned, C++ and Java, right? Now some of you may have heard of this or maybe have not, and also some of you may have maybe implemented something like this, or observed it, or maybe not. And if you haven't, then well, today will be your first exposure to it. But Java does this using threads, right? If you can create a Java thread, right? Essentially, you can have a function operating on one thread and other function performing on another thread, etc. It's these 2 or more functions, right, that are on threads, and these threads are performing these functions at the same time. And C++ does the same thing with threads, right? If you everyone's gonna have to take operating systems. Depending on the class, you may learn about, you may end up doing a demo or experimenting with creating threads in that class. So you might get a better or you might end up doing something yourself with that. But I will say threads can get very costly, and I'll explain that in a little bit. But in Go, concurrency can be done pretty easily, right? I think, compared to the other languages I've been talking about. And it's because it has these 2 built-in constructs, as I call it, or what the language comes with out of the box, being Go routines and channels. So Go routines. Go routines are essentially the threads of Go. They are function calls that can run independently, of the function that actually started it. So you can tell one function to, go run on a thread, and you can tell another function to go run on a thread, and you can tell a third function to go run on a thread, and etc. And they'll all be running without, conflicting with each other because they're on their same stuff. You don't have to wait for, let's say, function 1 to complete, or let's say we have a call for like function 1, function 2, function 3 in that order. Typically, if you call them, they will just perform in that order, right? Function 1 will, begin, then, it'll do its thing, then it'll end. And then, we have the function call for 2, it'll begin, do its thing, end, and same thing for the third one, right? But if we instead put them in Go routines and we call Go routines for function 1, 2, and 3, they're all going to perform at the same time. So, it's not going to wait for one to end before starting the next one. You can configure it like that, but it doesn't have to by default. And then Go also has channels. Now, channels are very helpful to Go routines. And what they are is they are a pipeline, or if that's what you want to call it, but it's a thing essentially in the language where you can send and receive data for a Go routine, right? It's an easy way to send the data to a specific Go routine, or if you want a Go routine to send data from one to another. They're kind of like the parameters. You kind of think of them as like parameters for a function, or parameters for a Go routine thread, but instead they're operated in channels, and you can send, as I mentioned, you can send the data from like one Go routine to another. So as I mentioned, as you can tell, like I've been, kind of talking about Go, and as I've been talking about it, comparing it to other programming languages, because I think it's kind of a good way to learn about it, since because Cal Poly learns about, pretty much their core language to learn is Java, which is a good one. And then you can take elective courses to learn like Python or C++. I think I don't know what other language offerings they have outside of that, other than like, I don't know, machine learning based, or like other programming languages and other programming paradigms, but like those are the core ones, I think. So I'm talking about Go from the being, compared to the other programming languages, because like I said, I think it's kind of a good way to understand, like, why you might want to choose this language as your go-to for a certain, problem domain, or, whatever you're developing. So I think in regards to concurrency, like specifically compared to other programming languages, it is like, I think, notorious and like regarded as being just simpler to implement and easier to implement, because it has simpler syntax to do what you want with concurrency. If I were to do one task in Go compared to like C++, I haven't had too great of experience doing concurrency in like C++. Honestly, I'm not like an expert in this department of concurrency, but the fact that like me not being an expert in it, but I can still do something, it says something about the language, right? So I think that should say a lot, right? Why this might be your go-to. So it's easier to implement, and it's also cheaper on the resources of like a computer and its operating system, right? It actually has lower memory usage. So, with now, if you compare Java to, Go's memory usage, if you have a Java thread that would require requires 2 megabytes of memory, that is, it's going to be more costly compared to a Go routine. as it will only require 2 kilobytes of memory. So that is that's a big win as well. Not only do you want to be able to, have this functionality done pretty easily, but you also don't want to take up too many resources in the computer if you don't have to. So I think that's awesome. All right, so that what I'll do is I'll actually show off something where I will show off the concurrency demo I have, right? So let me just get my terminals up, then I'll share my screen again. All right. How do I share? Oh, there it is. All right, so I think you all are able to see. Yep. Awesome. All right, so oops. Let me get rid of all these pop-ups. All right, so I have this code over here. Now this might be your first exposure. This might be your first exposure to Go, or like seeing the syntax of Go. Let me actually do this as well. Probably zoom that in a bit. So now, and I also did want to mention, I didn't say this before, but my purpose in like my demos and whatnot isn't to, show off like, okay, this is how you create a variable, this is how you create a function. I think a lot of that you're gonna kind of pick up on quickly if you, have already done, programming before, which I think some of you have, or obviously in the process, all right. You can transfer that knowledge over to this. All you need to know is simply the syntax and whatnot. So actually, what I'll do is I will first show that off. Where is it? Let me still sharing. Okay, yeah. So I've attached this this like Go cheat sheet at the end of this presentation, like a link to it. But this is like a very like simplified, condensed way of just like seeing, how to like, instantiate variables, for example, right? As you can see, you got your strings, you got your ints. It's actually, there's pretty efficient ways to do it, right? Like, you can do it all in one line, or you can make a list of variables. But this way, as you can see with all these ones, like you declare the types, but you don't have to declare the type sometimes if you do it like this. So, and then, this is how, to use pointers, because, this is kind of C++ like, you can still use pointers. How to do conditionals. It pretty much has all this stuff you kind of need just in case you forget something. You can kind of quickly refer to this. And it also does have stuff on Go on concurrency Go routines, but I'll show off a little bit of that. So I've attached this. I think if you know this combined with what any programming language that you may have already have or are learning, you can easily transfer it to Go. So that's my mindset when it comes to that. But let's get back into this. So what I have here is I have a program where I pretty much have a list, right? This is an array of numbers, right? And then what I want to do is I want to, iterate over all these numbers, this whole list of numbers, and just, print out, once it detects a odd number, then, it'll print out, odd, what the number is. Same thing, with the even numbers, right? So what I happened to do was, we're going to make threads for both of these functions, right? So pretty much I have a function to detect, to print out the odd number, same thing with the even number. So these are, two functions that I created. And then I've created Go routines over here for both of them, right? So they're both going to run at the same time. What I pass into it is actually that channel I was talking about, right? So it's these channels. What's going to happen is as we iterate over these numbers, if it detects an odd number or an even number, then, we're going to pass it into this channel odd. We're going to pass it into this odd channel, right? As we do here, right? So I'm iterating over the list. and we pass an odd number into the odd channel. And then, yeah, that's how it's conditioned over here, right? So let's go ahead and run this and see the output. Let me do this, copy. All right. Okay, so just went to the directory. Now, hold on, let me do this as well. Okay, I think y'all can see that pretty well. All right, so to run this program, it's pretty simple. Once you have Go installed, right? So I've Go installed. You can use the run command, right? It's pretty simple. You go run, and then you do the name of the program. Hold on. Let me make sure. I forgot to change this up a bit. So let me do this. Even odd. Go run even odd. All right. So as we see, let me do this. You see the output here, right? Odd, even. These were running at the same time, it wasn't that it printed out all the odd numbers first, right? Even though I established this thread first, right? Like in the code. But they were running at the same time, so we did get an odd number first, but then immediately after we got an even number. And then it was just going at the same time. So, and one thing about this is it will give the same output each time, like in the order of execution. That's another like issue in concurrency is like, is the output going to be the same each time? Is it going to always execute in the same order? But if we do it again, yeah. So, actually, yeah. See, so as you can see, right, the order changed up this time, right? So now, instead of odd, even, I got odd, even, odd. So, but yeah, that's just a little demo on how you can use channels to pretty much pass an input into these Go routines. And if I run it again, yeah, it changes up again, right? So order of execution is always like what's going to happen, but yeah, it does change up each time. So that's just a little bit about concurrency. Let me go back in here. Let me do this. Okay. Let's head back over here. But yeah, no, if you do want to learn more about concurrency, the resources I'll attach at the end will expose you to more like exercises and whatnot, like how this stuff works. So how concurrency works. All right. Now I want to move on to the process of garbage collection with this language. So to those that don't know what garbage collection is, it's an automated process of cleaning up the memory. When certain data in your program is created, right, with variables, objects, data structures, right, arrays, lists, dictionaries, and also any objects that you may have created, with any libraries or your user-defined classes, right? They all take up memory, right? I'm pretty sure a lot of us know that. But what we want to do is when it's not going to be used anymore by the program, right? When we use it, and then when the program is terminated, right? We need to make sure that it's removed from memory now, right? Other programming languages, as I mentioned, does not have this feature. And it's a very important feature to have, especially if your language is very predicated on efficiency and performance, right? And when you're having, as I mentioned, now if I go back to the example of like you have a lot of these requests coming in and you have a lot of data coming in, well, most likely you're going to be using a database, right? But just start at this level where you don't want the entire memory of a computer to be taken up, right? So other programming languages may not have this feature, or they do have it, but it's not as efficient, right? So C or C++, they don't have this feature of garbage collection, right? You need to, free memory manually, right? Using, and I remember learning C++ in my systems programming class, and having to always just worry about, okay, I'm gonna allocate this amount of memory, right, for this task or for this this data structure I'm gonna have, like an array I'm creating, right? And then I forget to free up the memory after I don't want to use the array anymore, like at the end of the program, right? Or the end of the array's usage. That always bugged me, to be honest. But in Go, it's going to be deallocated automatically. So, that's nice. But now if we compare it to Java, it does have a garbage collector as it's managed by, the JVM, the Java virtual machine. But, if you don't, the virtual machine doesn't always pick up everything, to be honest, since Java can vary, based on the Java version you have, it's going to have a different garbage collector and it's going to detect, however, it's programmed or, how it's developed. But, if you don't, for example, sometimes the garbage collector might not pick up some of the resources being used. So for example, a common thing is like, you make a scanner object, right, in Java, when you want to get user input. And you open that up, that's a resource that's being taken up in memory, right? But you have to make sure at the end of the program, if you want to make sure that there's no memory leakage, you have to close that scanner. And sometimes you may not forget it. Actually, if you go into an IDE and you create that and you don't close it, the program is actually going to give you a warning that memory leakage is going to occur. So that's another issue with something like Java, right? So yeah, that kind of shows, why Go is superior in that department. So, and yeah, as I mentioned, it's very vital for efficiency. So, now I'll show off a demo with this. So let me down here. I think you all can still see. Yep. All right. So I'm going to clear this up. And then now what I'll do is, let me garbage collection. Okay, yeah, I have it here. So what I'm gonna do is I'm gonna show off how Go does its garbage collection and how much more efficient it is in its garbage collection, and also just its memory usage in general compared to Java. So what I need to do is let me make a new window. Okay, because I'm going to run both a Java and a Go program at the same time, or yeah, I'm going to run them both. So let's do Java first. Let's see how Java does it. Okay, so let's copy this. So going to my Java program. Oops, got to do that. And then let's go ahead and let's first compile this. Right. First of all, let me also do this. So y'all can probably see it better. Okay. And then let me just make sure I CD into this. Okay, so let's run Javas first. So I already compiled the Java application. So I'll just kind of, I guess, briefly touch on this stuff. So pretty much what this is, with both programs, I'm making an array of size 90,000, and I'm just filling it with random values, to be honest. So I'm doing the same thing. And what I want to do is first, in both programs, I'm getting the used memory by the program, or I'm getting the used memory just in general in my computer, before we create the array and fill it up. Then afterwards, after all that's done, we see how much is used then, right? So we'll see, you know, how much memory is actually taken up by these arrays that I'm creating. So I'm gonna run the Java one now. So this one's in kilobytes. So this is how much it is. Seems to be. All right. So this is how much initially versus how much is used after we create the array, right? So you can see it's a big jump, right? Then if we get into the Go, how Go does it. Let's do Go run garbage collection, right? All right, so this is the big one to pay attention to, right? This is how much used memory before the array allocation in Go, right? 11,536. This is also kilobytes. And then, I can't see it. And then 13,289 after we create the array. So as you can see, it's like, it's kind of sizable, right? So, I mean, you're creating a lot of data in the back end, for example, or you're handling all this. And you also don't really, and let's say your computer only has so much memory, right? Which one are you going to use in this scenario, right? It seems like Go is the better option to use. So, but yeah, those are just a couple, you know, demos to kind of like show off, you know, why Go is a pretty, you know, nifty language for efficiency, performance, you know, by showing off, you know, how it does memory management, you know, it's automated, and also how it does concurrency. So let me switch back over to my presentation. All right, but yeah, those are pretty much the demos. Now I'll kind of leave the floor open to any questions and answers. So yeah. Does anyone have anything they would like to ask?
We have like
What's up?
So like,
Okay.
you know how like W3S has like learning for CSS and like JavaScript and all that. Like, is there like anything similar for the Go language that we could use?
Oh, like if you like want to go ahead and like keep learning GoLang and whatnot.
Yeah.
Yeah, so this is my last slide actually. But yeah, I attached some resources. So you know, that cheat sheet that I showed off earlier, right? That's this link I have up here. Actually, can I do this? Are y'all able to see this like red dot, this laser pointer?
Yeah.
Okay, cool. I think this is cool to use. But yeah, over here, right, I have the cheat sheet, and then also W3 Schools tutorial. It's actually a pretty nice one. If you don't want to like use a video, it kind of just like lists on like the left-hand side there, like whatever, you know, topics, right? And also a video playlist as well that I think is pretty good. So yeah, you can go ahead and take these on, or go ahead and, you know, Google your own like you know, GoLang tutorial. You can take a whole course in it if you would like to. But, you know, I think you can learn a lot just, you know, by Googling stuff, watching YouTube videos, that sort of thing. So yeah, hopefully this helps. And then also I did attach like more in-depth, like if you want to read up on Go routines and Go the channels and like how they're used. These websites are actually pretty good for that, and like how they're used together, if you want a better understanding. So yeah, hopefully that helps. Did that answer the question?
Yes. Just said it. Thank you, Ketan. Thank you.
All right, awesome. Yeah, of course. Anything else? Yeah. I'm open to questions also outside of like, you know, not even just about this too, so.
Okay, wait, so Keaton, like you said, like during your internship, you used Go for a lot of things. So like, what kind of what application do you use Go with? Like, during your time of internship, because like, you can use Go for basically almost anything, but like, what do you use it for? Do you use it for like, back-end web development, like, network or anything like that?
Yeah, so actually, you know what we used it for? It was pretty cool actually. So at the time when I was working at Toyota, what they were trying to do is they were trying to experiment with, like the cars implementing like cellular data into it, right? AT&T to be specific, right? And we're testing out stuff like that. I was on the side of like testing out the API and whatnot. And actually I did this internship with my friend too. And what he had to do was on the like the actual like head unit of a car, you can they had the feature where like you can subscribe to a cellular data subscription straight off of the head unit on the car, which was pretty cool. What he had to do was he had to test out using Go how many users it would handle before it would break maybe the system, right? Like he would have to increase the amount of test users and it would increase. So that's what he used it for, or that's what we were using it for, essentially. So that was one of the use cases. And that's where like, the Go channels or the Go routines were being used in that sense, so yeah, that was one of the use cases for it.
Okay, thank you, Keaton. We have to finish up now.
Okay.
Next one.
No, it's all good. Sounds good. But yeah, I think like they attached my like LinkedIn in the announcement. So yeah, if anyone ever wants to reach out about anything, just feel free to do that. I'm always open to it. So yeah. Yeah, thank you to CSS, Kayla, Joey, and Fu for
Thank you, Keaton.
yeah, of course. Yeah. Thank you all for having me back. It was a pleasure as always.
From the host.
Okay, thank you,
Moved
Keaton.
from the host. We love you. Come back soon.
Come back
All
soon,
right, yeah.
visit us, Keaton, one day.
Yeah, of course. Yeah, definitely. We'll keep in touch.
Thank you for coming.
All right, sounds good. Everyone.